Yeah, good morning everyone. This is Rajaarjun, working as Assistant Professor in the Department of Basic Science and Humanities, BVRIT, Narsapur. So, today we'll discuss about polymers. So, we all know that polymer is a Greek word. So, polymer, it is a Greek word. So, in Greek, poly means many and mer means unit or atom. Poly means many and mer means unit or atom. So polymer is nothing but it is a high molecular weight compound formed by the joining of large number of small molecules or small atoms. So the process of joining together of large number of small molecules or small atoms to form very big molecules is termed as polymerization. Right? That overall process is called polymerization. And the small molecules which combine with each other to form very big molecules are termed as monomers. So polymerization, right? Overall process is known as polymerization. That small molecules which combine with each other to form very big molecules are termed as monomers. Right? So examples of polymers are polythene, polyvinyl chloride, right? Polythene, polyvinyl chloride, PVC, Teflon, nylon, etc. For example, let us take polythene. First example number 1, that is polythene. So polythene is formed by the polymerization of ethene. That is, so in chemistry, it means 2 carbons and ene means double bond. So polythene. So what should I write here? N moles, right? Polythene, that is CH2 double bond CH2, right? This is ethene, right? Ethene, CH2 double bond CH2 in presence of peroxide to give, what should I write here? Instead of double bond, what should I write here? CH2 single bond CH2, which is nothing but polythene PE. Right? So polythene is formed by the polymerization of ethylene. Next, second one, polyvinyl chloride, which is nothing but PVC, polyvinyl chloride. Name itself indicating vinyl chloride. So polyvinyl chloride is formed by the polymerization of vinyl chloride. So what is vinyl chloride? That I'll write here. N moles of vinyl chloride, CH2 double bond CHCl. This is nothing but vinyl chloride, right? So what should I write here? PVC, polyvinyl chloride. That is CH2 instead of double bond, single bond CHCl. Next CH2, CHCl, like that, N moles, right? So this is about PVC. right? So polyvinyl chloride. Polyvinyl chloride is formed by the polymerization of vinyl chloride. Next, one more example, that is bakelite, right? Example number 3 is uh, bakelite. We all know that this bakelite is thermosetting polymer. So bakelite is nothing but phenol formaldehyde resin. Bakelite is formed by condensing phenol with formaldehyde, right? This overall process we'll discuss later, preparation of bakelite. So monomers are nothing but phenol and formaldehyde. That is nothing but bakelite, right? So this is about bakelite. Bakelite is formed by condensing phenol with formaldehyde. Next, the last one, polystyrene. Polystyrene. Again, polystyrene. So polystyrene is formed by the polymerization of styrene. So my question is, what is styrene? So styrene is nothing but vinyl benzene. Vinyl benzene is called styrene. Vinyl benzene is called styrene. That is, here I am writing C6H5, C6H5, CH double bond CH2. This is vinyl group, and this one is nothing but benzene. Vinyl benzene, N moles, right? In presence of H2O2 to give polystyrene, that is C6H5 CH. Instead of double bond, what should I write here? Single bond CH2. Next CH, C6H5 CH2, and so on. This is polystyrene. PS, polystyrene. So polystyrene is formed by the polymerization of styrene, right? So this is about introduction of polymers, right? Next, classification. Now we'll discuss about classification. So polymers can be classified in several ways. So classification number 1, that is based on structure. Based on structure. First classification, based on structure. So based on structure, polymers are of 3 types: linear chain polymers, branched chain polymers, and cross-linked polymers. Linear chain, here I am writing linear chain polymers, linear chain polymers. Next, branched chain polymers, branched chain polymers. And one more, that is cross-linked polymers. Cross-linked polymers. Right. So first one, linear chain polymers. So in linear chain polymers, all the monomers are arranged in the form of chain. In the form of chain. All the monomers are arranged in the form of chain, and these polymers possess high melting point and high density. High melting point and high density, that is due to a well packed structure. right? So all the monomers are arranged in the form of chain, in the form of chain, right? Where M is equal to monomer, where M is nothing but monomer, right? So all the monomers are arranged in the form of chain, and these polymers possess high melting point and high density, right? Where M is equal to monomer. Next, coming to branched chain polymers, name itself indicating branches. So in these polymers, the polymeric chain contains branches of monomers, actually which hinders the close packing structure of polymeric chain. So hence, these polymers are less tightly packed in comparison to linear chain polymers. And these polymers possess low melting point and less density. Low melting point and less density. Low melting point and less density. Branches of monomers. That is, branches of monomers. Branches. Where M is equal to monomer. Where M is equal to monomer. And these branched chain polymers are less tightly packed in comparison to linear chain polymers. So that's why these branched chain polymers possess low melting point and less density. So this is about branched chain polymers. Linear chain, branched chain, and one more, that is third one is cross-linked polymers. Third one is cross-linked polymers. Cross-linked polymers. Right. So in cross-linked polymers, right, all the monomers are cross-linked together in all three dimensions. In all three dimensions, cross-linked together like this. In all three dimensions. This is nothing but cross-linked polymer where M is equal to monomer. Where M is nothing but monomer. Monomer. Okay. So this is about cross-linked polymer. So based on structure, polymers are of three types: linear chain, branched chain, and one more, that is cross-linked polymers. Right. Next, classification number 2. Classification number 2, that is based on types of monomers. Based on types of monomers. So based on types of monomers, again polymers are of two types. Homopolymers, one sec. Homopolymer and copolymer. Homo and one more, that is copolymer. Homo and copolymer. So homopolymer. So it is nothing. Homopolymer is nothing but it is formed by the polymerization of one type of monomer, one type of single type, one type of monomer. That is nothing but Na gives rise to An, one type of monomer. Homo, one type. So Na gives rise to An, where A is equal to monomer, where A is nothing but monomer. Okay, so it is formed by the polymerization of one type of monomer, homo polymer. Next, second one, that is copolymer. Copolymer, when two different types of monomers are arranged in the same polymeric chain, then the polymer is said to be copolymer. Then the polymer is called copolymer. For example, let us consider two different types of monomers A and B, which can be joined in many ways. Suppose if two different types of monomers like A and B are arranged in alternating fashion, in alternating manner, AB, alternating manner, then the polymer is called alternating copolymer. Alternating copolymer. Alternating copolymer. Right. If two different types of monomers A and B, right? Two different types of monomers like A and B are arranged in random manner, then the polymer is called random copolymer, right? Random manner. Random. This is random copolymer. Random copolymer. Okay. So based on types of monomers, again polymers are of two types, homopolymer and copolymer. Homopolymer is nothing but it is formed by the polymerization of one type of monomer, that is Na gives rise to An, where A is equal to monomer. Next, copolymer. So when two different types of monomers are joined in the same polymeric chain, then the polymer is called copolymer. So in copolymer, again we have alternating copolymer and random copolymer. So if two different types of monomers like A and B are arranged in alternating manner, then the polymer is called alternating copolymer. Next, if two different types of monomers are arranged in a random manner, then the polymer is said to be what? Random copolymer. Right? So this is about classification based on types of monomers. Second classification, types of monomers. Next, classification number 3, that is third classification. Classification number 3, that is based on tacticity. Based on tacticity. Nothing but configuration. Tacticity, configuration. So again, based on tacticity, again polymers are of 3 types. That is isotactic polymers. Next, syndiotactic polymers. And third one is atactic polymers. Atactic polymers. Isotactic, symbiotic, and atactic. Isotactic, symbiotic, and atactic. Now we'll discuss about isotactic, right? So isotactic polymer, that I'll write here. So isotactic polymer, polymeric chain C3, 4, 5, 6, 7. Isotactic. So here R is nothing but functional group. R is nothing but functional group. This is isotactic polymer. Isotactic polymer. Yes, isotactic polymer. Okay. So here, this is isotactic polymer, where R stands for what? functional group. So in isotactic polymer, all the functional groups are arranged on the same side of the polymeric chain. If all the functional groups are arranged on the same side of the polymeric chain, then the polymer is called what? Isotactic polymer, right? Isotactic polymer. All the functional groups are on the same side of the polymeric chain, right? This is isotactic. Next, coming to syndiotactic. So in syndiotactic, all the functional groups are arranged alternatively. All the functional groups are arranged alternatively on both the sides of the polymeric chain. That is, that I'll write here, syndiotactic. So what I said, functional groups. All the functional groups are arranged alternatively on both the sides of the polymeric chain. Alternating manner. Alternating manner. This is syndiotactic polymer. Okay. So alternating manner, right? Alternating fashion. Then the polymer is called syndiotactic. Next, atactic polymers. So in atactic polymers, all the functional groups are arranged randomly on both the sides of the polymeric chain. Random manner. Random manner means what? Atactic polymer. That is 4, 5, 6, 7. Random manner. That is random manner, where R is functional group, hydrogen, up. So randomly, right? So in atactic polymers, all the functional groups are arranged randomly on both the sides of the polymeric chain. So same side means isotactic. Alternating means syndiotactic. Random manner. Randomly means atactic. So classification number 3, based on tacticity, isotactic, syndiotactic, and third one is atactic. Okay, so this is about classification number 3, tacticity configuration. Next, classification number 4, that is fourth classification. Classification number 4, based on synthesis. Yeah. So based on synthesis. Again, polymers are of two types. Addition polymers and one more, that is condensation polymers. Addition and condensation. Addition polymers and condensation polymers. Addition polymers. So these are addition polymers are formed by the polymerization of monomers without elimination of atoms or groups, right? without elimination of atoms or groups, right? Formed by the polymerization of monomers without elimination of atoms or groups. The examples of addition polymers are polythene, polyvinyl chloride, PVC, polystyrene, Teflon, etc., etc., etc. So PVC, PE, PS and Teflon comes under addition, right? So addition polymers are formed by the polymerization of monomers without elimination of atoms or groups. Next, coming to condensation. So condensation polymers. So here in condensation polymers, condensation polymers are formed by the polymerization of monomers with the elimination of atoms. With the elimination of atoms or groups. Like water, alcohol, ester, etc., etc., with the elimination of atoms or groups, right? So examples of condensation polymers, right? Examples of condensation polymers are right? Very familiar, that is nylon 6,6, terylene, etc., etc., etc. So with the elimination of atoms, right? Now let us take this nylon 6,6 preparation. So this nylon 6,6, right? What is condensation? Condensation is nothing. Condensation polymers are nothing but it is formed by the polymerization of monomers with the elimination of atoms. With the elimination of atoms or groups. Alcohol, water, etc., etc. Right? So nylon 6,6 preparation. So nylon 6,6 can be prepared, right? So here in nylon 6,6 monomers are hexamethylene diamine monomers, and adipic acid. Hexamethylene diamine plus adipic acid gives rise to nylon 6,6. So first I will write hexamethylene diamine, that is hexamethylene, that is CH2 taken 6, hexamethylene diamine, NH2, hexamethylene diamine, N moles, hexamethylene diamine, and one more, that is plus, what should I write here? Adipic acid, that is dicarboxylic acid, CH2 taken 4, COOH and COOH, hexamethylene diamine and adipic acid. This is nothing but dicarboxylic acid. So loss of water, H and OH minus NH2O, loss of water. So what I said, condensation polymers. Condensation polymers are formed by the polymerization of monomers with the elimination of atoms or groups like water, alcohol, etc., etc. So what should I write here? Here I am writing final product. Here I am writing, that is NH2 or NH, CH2 taken 6, NH, right, loss of water, right, NH, C double bond O, CH2 taken 4 and so on. This is nylon 6, 6 condensation polymer, nylon 6, 6. So this is about based on synthesis. So based on synthesis, again polymers are of two types, addition polymers and condensation polymers, right? So addition polymers are nothing but formed by the polymerization of monomers without elimination of atoms or groups. And examples of addition polymers are polythene, polyvinyl chloride, styrene, polystyrene, Teflon, etc. etc. And condensation polymers are nothing but it is formed by the polymerization of monomers with the elimination of atoms, or groups. And examples are nothing but terylene, nylon 6, 6, right, etc. etc. So four classification. First classification is based on structure. Based on structure, again polymers are of three types: linear, branched, cross-linked. Classification number 2, that is based on types of monomers: homopolymer and copolymer. Next classification number 3, that is based on configuration, tacticity, isotactic, symbiotic, and atactic. Fourth classification is synthesis. Based on synthesis, addition polymers and condensation polymers, right? So this is about classification, right? Now we'll discuss about free radical addition polymerization. Free radical addition polymerization. Next topic, that is free radical addition polymerization. Free radical addition polymerization. Okay. So in free radical addition polymerization, monomer is activated by the action of light, heat, or by adding chemicals. Action of light, heat, or by adding some chemicals known as initiators. And the examples of initiators are benzyl peroxide and one more, that is AIBN. One is benzyl peroxide, right? And formula for benzyl peroxide is C6H5 CO O C6H5 CO C6H5 CO C6H5, and one more, that is AIBN, that is azo-bis-isobutyronitrate. These two are nothing but initiators. So monomer is activated by the action of light, heat, or by adding some chemicals known as initiators. Right. Now we'll discuss about mechanism. So this free radical addition polymerization, it consists of three steps. Step 1, that is initiation. Step 2, that is propagation. Step 3, that is termination. Initiation, propagation, and third one is termination. So first Step 1. Step 1, that is initiation. So in initiation step, always formation of reactive particles takes place. Formation of what? Reactive particles. Here reactive particle is free radical. So formation of free radicals takes place. Formation of free radicals. Free radicals takes place. And this initiation, it involves two stages. It involves two stages. So first, stage 1, that is formation of free radicals. Formation of one sec, yeah, free radicals. So generally these free radicals are generated by the action of heat on them. By the action of heat. That is, here I am writing I, which upon heating gives free radicals R dot, where I is nothing but initiator. I is initiator and R dot is nothing but free radical. Right. Free radicals are formed by the action of heat, on them, generated by the action of heat on them. Right. So for example, in this mechanism, initiator is nothing but benzyl peroxide. And formula, we all know that formula for benzyl peroxide is C6H5 CO OOCO C6H5. Right, which upon heating, right? So this benzyl peroxide, it undergoes homolytic fission, and we all know that in homolytic fission always formation of free radicals takes place, right? Oxygen bond, OO, this bond breaks here, right? So what should I write here? 2 moles of C6H5 COO dot, that is 2 moles of C6H5 COO dot, right? Which upon further heating, right? Which upon further heating, evolution of carbon dioxide, it evolves carbon dioxide and resulting in the formation of phenyl radical. Phenyl radical, that is nothing but C6H5, right? It evolves, which upon further heating evolves carbon dioxide and resulting in the formation of phenyl radical, that is nothing but Cr dot, right? R dot, where R is equal to, which is represented as C6H5 or otherwise phenyl radical. Here where R is equal to phenyl radical, right? Am I clear? So step 1, that is initiator. Initiator is benzyl peroxide. It undergoes homolytic fission, oxygen cleavage, right? Homolytic fission. And in homolytic fission, always formation of what? Free radicals takes place. So what should I write here? 2 moles of C6H5 COO dot, which upon further heating, it evolves carbon dioxide and resulting in the formation of phenyl radical, that is nothing but R dot, where R is equal to C6H5. This is stage 1, formation of free radicals. Next, stage 2. That is addition of free radicals. Addition of free radicals or addition of free radical to the first monomer. here monomer is nothing but olefin, that is, so this formed phenyl radical, right? Formed phenyl radical, which is nothing but R dot, it reacts with monomer, that is CH2 double bond CHY. Substituent is nothing but Y, right? Monomer. And this monomer, it undergoes homolytic fission, right? Homolytic fission, carbon-carbon bond, right? Homolytic fission. So this electron moves here to make a bond with R dot, and this another electron moves here to form chain initiated species, right? This electron moves here to form a bond with R dot, that is bond between R and CH2. What should I write here? RCH2, right? And another electron moves out here to form chain initiated species, CH dot, chain initiated species, right? So this is about step 1. What is step 1? Step 1, initiation. In initiation, formation of free radicals, right? Formation of free radicals, right? So this initiation step, it involves 2 stages. Initiation step involves 2 stages. Stage 1, that is formation of free radicals. So here, like I said, in this mechanism, initiator is benzyl peroxide. This benzyl peroxide, it undergoes homolytic fission, right? So 2 moles of C6H5COO dot, which upon further heating, it evolves carbon dioxide and resulting in the formation of phenyl radical, which is nothing but, which is represented as R dot. R dot. Next, stage 2. What is stage 2 here? Addition of free radicals to the first monomer. So this formed phenyl radical or R dot, it reacts with monomer, right? And this monomer, it also undergoes homolytic fission, right? This electron moves here to form a bond with R dot, and another electron moves out here to form chain initiated species, right? So this is about step 1, initiation. Next, step 2. What is step 2 here? Propagation. Step 2 is nothing but propagation. Propagation. Step 2 is nothing but propagation. So this chain initiated species, which is nothing but RCH2CH dot Y, right? So this propagation, actually it involves the growth of polymeric chain, involves the growth of polymeric chain, that is growth of polymeric chain. So here in propagation, this formed chain initiated species, which is nothing but RCH2 CH dot Y, chain initiated species, it reacts with monomer CH2 double bond CHY. So same concept, again homolytic fission. We all know that in homolytic fission, formation of what? Free radicals. Formation of free radical takes place. So here, this electron moves here to form a bond with CH dot, and another electron moves out here to form again chain initiated species, which is nothing but, here I am writing R done. Next, R followed by CH2 done. Next, CHY, right? Bond between CH and CH2. CH and CH2. So what should I write here? CH. Next bond CH2, single bond CH2. Next single bond CHY. free radical or chain initiated species. Or this formed chain initiated species, again it reacts with monomer, that is olefin CH2 double bond CHY, and resulting in the formation of living polymer, right? Living polymer. Here I am taking N times, right? So same concept again, bond cleavage. This electron moves here to form a bond with CH dot, and another electron moves out here to form chain initiated species. So that's why I'm taking N moles here. So what should I write here? Living polymer, and the reaction goes on. So what should I write here? Living polymer, that is RCH2 CHY done. Next CH2 CH dot Y taken N times, CHY, one second, CHY taken N times, So this polymer is called living polymer, right? So this is about step 2, growth of polymeric chain. It involves the growth of polymeric chain, right? Step 2. Next, termination. So in termination step, the growth of polymeric chain is finally terminated. The growth of polymeric chain is finally terminated. End of the reaction. So termination can be done by coupling. It can be done by coupling chain initiated species. Right. That is, here I am taking 2 chain initiated species, that is RCH2 CHY CH2 N times CH dot Y, plus by coupling 2 chain initiated species, again same CH dot, one more chain initiated species, that is CHY CH2 CHY N times CH2R, right? By coupling 2 chain initiated species, bond between CH and CH, that is final product is a dead polymer, that is what should I write here? Bond between CH and CH, Y. Next this moiety, that CH2 CHY taken N CH2R. Next CH2 CHY N times CH2R, right? See, growth of polymeric chain is finally terminated here. This type of polymer is nothing but it is known as dead polymer. Here you won't find any free radical molecule, right? So this type of polymer is nothing but dead polymer, known as dead polymer. Okay, so this is about free radical addition polymerization. Initiation, this mechanism consists of 3 steps: initiation, propagation, and termination. So initiation. In initiation, always formation of reactive particles. Formation of reactive particles takes place. So here reactive particle is nothing but free radical. So formation of free radicals takes place. That is step 1. Next, step 2, that is propagation. Propagation, it involves the growth of polymeric chain. Right? Growth of polymeric chain. Next, step 3 is termination. The growth of polymeric chain is finally terminated here. That is nothing but end of the reaction, chemical end of the reaction, right? By coupling two chain initiated species. So this is about free radical polymerization. So thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.